Hi there, welcome to this video where we continue taking a look at Bertrand Russell's Principles of Mathematics. So in this video, I'm going to make a start on chapter 3, Implication and Formal Implication. So in the last few videos, I did chapters 4, 5, and 6. So I'm not necessarily, what I'm hoping to do is to make a set of videos, a series of videos that looks at really the whole of part 1 of Principles of Mathematics and maybe even beyond that, but I'd like to have a set of videos that looks at part 1 of Principles of Mathematics. But I'm not necessarily doing the videos in the order in which the chapters appear in Principles of Mathematics. There's various reasons for that. One of the reasons is that it just depends. Well, it depends what I feel like doing, really, first and foremost. Second of all, it depends what I think I've got the clearest ideas around, because some of these chapters I've got to read several times really to form some kind of idea about what I think Russell is talking about. And in some of the chapters are very I've got some very vague ideas that I need to think a bit more about before I'd feel comfortable making a video. Indeed, even this one that I'm making now on chapter 3, the ideas that I express they're not definitive. They're provisional ideas. It's very difficult to figure out exactly what Russell means in Principles of Mathematics. Obviously, he's not alive anymore for us to ask for any sort of clarification. But also, there's not really any commentaries or anything like that on Principles of Mathematics for you to refer to, and I don't know anybody personally who knows about Principles of Mathematics that I could kind of bounce ideas around with and try to get some sort of clarification. It's not like say Immanuel Kant or something like that, where there's tons of commentaries on Immanuel Kant's Critique of Pure Reason, and you go into any philosophy department at a university, there's bound to be somebody there that knows about Immanuel Kant that you can ask questions, and you can get some fairly solid answers, not necessarily definitive, but you can talk about things in detail. With Principles of Mathematics, what I find is I'm on my own. So it can be quite difficult to form ideas. If you're on your own, sometimes if you get stuck with an idea and you can't really take it any further, then you're stuck and you can't go any further until the time comes that you manage to figure it out, which maybe never. So it just happens that chapter 3 is the chapter at the moment that I feel that I'm most ready to talk about, even though as we go through this video, and probably in the next one, so I'm probably going to have to make 2 videos on this chapter, still a lot of the ideas that I express are going to be quite vague. So please don't watch this expecting nice, definitive, clear explanations and interpretations of Russell's work. But another reason why I'm not necessarily going through in the strict order in which the chapters appear in the book is because actually, in many ways, there's no need to do that. Principles of Mathematics, from my experience, doesn't work in a purely single unidirection. It doesn't have a single direction to it. It's not like a textbook where everything builds on what's gone before. There's sometimes let's say to understand chapter 4 in Principles of Mathematics, you might have to be quite patient and wait until you've read something in, I don't know, chapter 15. And then you kind of referring backwards and forwards sometimes. I mean, there is a general tendency in the forwards direction, but there are things that he talks about that actually kind of refer to things later in the book. So he talks about propositional functions, for example, in some of the early chapters. In chapters 2 and 3, I think, he talks about propositional functions. But he doesn't cover propositional functions until chapter 7. He talks about classes in some of the early chapters, but he doesn't get around to talking about classes until chapter 6. So in a way, it doesn't really, I wouldn't say it doesn't make any difference which order I go through the videos, but through the chapters in these videos, but it's not necessarily as important for me to go through chapter 1, chapter 2, chapter 3 in that order, in that strict order. It's not really necessary for me to do that. But also chapters 1 and 2, there's not a massive amount for me to say. Even if I were to go through chapter 1, chapter 2, chapter 3 in order, actually chapter 1, there's not really a great deal for me to say about chapter 1. I will do at some point a video, or however many videos I need to do, on chapters 1 and 2. But there's really not much for me to say about them. There are some few points that I need to make or want to make, a few observations, but generally speaking, chapter 3 is the first chapter, in my opinion, where there's a lot to think about. Okay, so as usual, this video is going to be unscripted, so I will be gathering my thoughts from time to time. And as I've said, some of the ideas that I expressed in this video are going to be quite provisional. I've not had a chance to discuss these ideas with anybody. So in a way, this video is me actually clarifying to a certain extent in my own mind some of the ideas that I have, seeing how I can express the ideas. So if I do start to ramble on a bit, then that's, take it or leave it. The video is what it is, and what you see is what you get. Okay, so maybe further down the line, once I've done my videos and I feel like I've got some nice, clear enough ideas, maybe I will kind of refine everything down and make a series of videos where it's a bit more, there's a bit more flow to the videos and a bit more certainty. But for the time being, the ideas come out however they come out. And it would be really great if there are any people out there that know about principles of mathematics and see where I'm going wrong or misinterpreting things. You know, it'd be really great if you could get in touch. If anybody does have any questions about what I say in these videos or my other videos, please feel free to ask. I'll be happy to help wherever I can. That reminds me, I'd be really grateful if you would consider hitting the subscribe button, hitting the like button, and leaving a nice positive comment in the comments section. It's always much appreciated. So let's make a start then with chapter 3, Implication and Formal Implication. So I will be referring to some other parts of principles of mathematics without necessarily bringing up on the screen. I will have up on the screen that roughly the part of the chapter that I'm talking about, but because where the page ends in my book that I'm reading from here doesn't necessarily correspond to where the page ends on the digital copy that I've got here on the screen, then sometimes I can forget, so I can carry on reading and not realize that I've not changed the page on the screen. So if you do have your own copy of Principles of Mathematics, digital copy, hard copy, doesn't make any difference, that would probably help a little bit, just in case I do forget to change the page. Okay, so let's make a start then. Some parts, some of the sections, there's not really going to be much for me to say. Other parts, there's going to be quite a lot that I want to get off my chest. Some parts I don't understand to this chapter. I don't understand very well. I might make some attempts to try to explain what I think is going on, but there are all sorts of paragraphs that I don't really understand what Russell's getting at. So I'll try my best anyway. As I said, it's all provisional. There's nothing definitive. It's all subject to change. So, section 37. In the preceding chapter, I endeavoured to present briefly and uncritically all the data in the shape of formally fundamental ideas and propositions that pure mathematics requires. In subsequent parts, I shall show that these are all the data by giving definitions of the various mathematical concepts, number, infinity, continuity, the various spaces of geometry and motion. In the remainder of part 1, I shall give indications, as best I can, of the philosophical problems arising in the analysis of the data and of the directions in which I imagine these problems to be probably soluble. So Russell doesn't necessarily resolve all of the problems that he highlights in this book. And this is kind of, it can be a little bit frustrating sometimes when there's no definitive answer. He just kind of throws out some issues, highlights some issues. He might, in some cases, indicate some possible directions to go in to try to resolve those issues. But sometimes he does just hold his hands up and say, I don't know what to do here. Somebody else is. Either I'm going to have to come back to this at a later time because it's not really relevant to what we're doing here, or somebody else is going to have to push it forward. Some logical notions will be elicited which, though they seem quite fundamental to logic, are not commonly discussed in works on the subject, and thus problems no longer clothed in mathematical symbolism will be presented for the consideration of philosophical logicians. So that's that last sentence there is quite important in my opinion. So I've said I briefly talked about this in another video. And by the way, the videos that I've made so far are on chapters 4, 5, and 6. Since I've already done those, I will potentially refer to things that I've said in those videos. So again, I'm not doing things in the strict order in which they appear in the book. So even though something that I've spoken about maybe in chapter 6, it comes after, obviously, chapter 3, I may still refer to it because it might help us better understand something in chapter 3. Remember what I said a few minutes ago, that sometimes reading something in a later chapter actually better helps you better understand something in an earlier chapter. And be prepared when it comes to principles of mathematics to read it multiple times. Read sections, chapters, parts multiple times. It's not the kind of book at all that you can just kind of read through once and expect to get all of the nuance from it. There are sections of this that I've read dozens and dozens of times. And I wouldn't say that I've got to a point, anywhere near a point where I've linked up all of the relevant bits of information. It's so dense. One of the reasons why I go through principles of mathematics in the way that I do in these videos is because to me it's just so difficult to try to condense it down to a few bullet points. It just doesn't work. There's just so much information there that's arguably relevant at various times throughout the work. It's so difficult to try to condense things down. But what he says here about problems no longer clothed in mathematical symbolism will be presented for the consideration of philosophical logicians. What I've said in a previous video is that when you've got symbolism entering into the situation, mathematical symbolism, what can happen is, and this is no bad thing, by the way, to introduce a symbolism. You can say things usually much more efficiently, much more clearly, and much more effectively using a symbolic notation. But what can happen is that you're using symbols to represent something. And what can happen is the attention is almost exclusively on what is symbolizing as opposed to what is being symbolized. So the questions that you start to ask often become more about what kind of symbolic transformations can I make in this symbolic language, and questions about the specific nature on a philosophical level, say, of the objects that are being symbolized can they get dismissed almost in some cases. the focus is on the symbolism and the various symbolic manipulations valid symbolic manipulations that you can make. And this is not necessarily a bad thing, but when you're trying to look at things from a more philosophical perspective, and you're trying to look at the object that is being symbolized, the notation, the symbolic notation, can kind of stand in the way. So by taking that out of the situation, you've got a much more clear view, so to speak, with this thing that you're trying to analyze from a philosophical perspective. We saw this in chapter 6 when it comes to the null class. There's a symbol for the null class, okay? But when Russell tried to analyze the null class from a philosophical perspective, he found that there isn't such a thing. There isn't a null class. But we have a symbol for it, and we need a symbol. Indeed, we need a symbol to represent this thing called the null class. But there isn't a null class in his view. It's a fiction. So the kinds of conclusions that we might end up drawing when we're looking at things through the symbolism, they're different to the conclusions that we might draw from when we're getting a much more direct view of the thing that we're trying to analyze. Now, symbolism does help in a way. As I said, it can express things in a much more succinct and clear way in many respects, but it can also bring certain problems that you, as we've just seen with the null class. So I'm not saying that symbolic notation shouldn't be used, but it does kind of take the focus away from, if you're wanting to analyze something from a philosophical perspective, and you need a much more direct view of it, the symbolism can get in the way. So you kind of got to. I don't know if that's why Russell takes the symbolism away, or doesn't seem to use symbolism too much. It can be very frustrating from the perspective of mathematics. Because you look through principles of mathematics, it's words. There's a bit of symbolism here and there, but it's typically words. So from coming at this from a perspective of a mathematician, say, you're thinking, why not just use symbolism? Why not just use symbols? And you get to the point much more quickly. And that might be true, but then the attention, the focus is shifted onto what is symbolizing as opposed to what is being symbolized. So I think that's what he's kind of saying there. So two kinds of implication, the material and the formal, were found to be essential to every kind of deduction. In the present chapter, I wish to examine and distinguish these two kinds, and to discuss some methods of attempting to analyze the second of them. In the discussion of inference, it is common to permit the intrusion of a psychological element, and to consider our acquisition of new knowledge by its means. So just, I've put a little note here, so on my page 11. So if we read section 12, right at the beginning of section 12, the first sentence is, symbolic logic is essentially concerned with inference in general. And then there's a note corresponding to that. And the note reads as follows: I may as well say at once that I do not distinguish between inference and deduction. What is called induction appears to me to be either disguised deduction, and that to me, I think he's talking about mathematical induction there, which is effectively just another form of deduction, or a mere method of making plausible guesses. So that's genuine inductive reasoning used in the inductive sciences that he's talking about. But the upshot is he doesn't distinguish between inference and deduction. So, where was I? But it is plain that where we validly infer one proposition from another, we do so in virtue of a relation which holds between the two propositions, whether we perceive it or not. The mind, and I don't know exactly what Russell means here by mind, so I use the word mind, for example, and I guess I've got a vague idea what I mean by this, but certainly no precise definition of what I mean by mind when I use that word. it would be interesting to know what Russell's view of mind was at the time of writing Principles of Mathematics. He did publish a book some years later called Analysis of Mind. I've got a copy in my bookcase. But that was published sometime after Principles of Mathematics, so I would expect that his view would have changed in that time as to how he viewed the concept of mind. It would be really interesting to know what he meant by mind at this point in time. We'll probably never know, but on we go. The mind, in fact, is as purely receptive in inference as common sense supposes it to be in perception of sensible objects. So inference is something that we perceive, or that the mind perceives, as clearly as sensible objects, in other words. The relation in virtue of which it is possible for us validly to infer is what I call material implication. So material implication is a relation between actual propositions. We've already seen that it would be a vicious circle to define this relation as meaning that if one proposition is true, then another is true. For if and then already involve implication. That's what implication means. If this, then that. So if we try to define implication in terms of this if and then, we're defining implication in terms of itself. And that's what he's talking about with it would be a vicious circle. The relation holds, in fact, when it does hold, without any reference to the truth or falsehood of the propositions involved. So, this relation exists between certain propositions. Some propositions we call true, some we call false. But this relation makes no reference to that. It's just a relation which exists between certain propositions. There are certain patterns that we might establish once we start assigning true and false to propositions, if that's something that we do. But the relation itself makes no reference to truth or false. It's just something that it's just a relation which exists between certain propositions. But in developing the consequences of our assumptions as to implication, we will lead to conclusions which do not by any means agree with what is commonly held concerning implication. For we found that any false proposition implies every proposition, and any true proposition is implied by every proposition. Those propositions are formally like a set of lengths, so he's drawing an analogy here, like a set of lengths, each of which is 1 inch or 2, and implication is like the relation equal to or less than among such lengths. So if we can, if we're somehow able to make a form of one-to-one correspondence between propositions and these lengths of 1 or 2 inches, so every true proposition corresponds to a length, I suppose it would be length 2, won't it? And every false proposition corresponds to a length 1, then effectively we've got, I don't know what word you might use, kind of an isomorphism or something like that, or one-to-one correspondence between implication and this implication between propositions and the relation equal to or less than amongst these lengths. Whenever we've got that this length is equal to or less than that length, then the propositions, there is the relation of implication that holds between the two propositions that these lengths correspond to. So it's just an analogy, but he's pointing out that that there's these unusual properties of implication that we might not be used to. Bearing in mind that this book was it was published in 1903, when symbolic logic was kind of in its infancy, and the kind of formal notion of implication, which we're kind of used to. If you're familiar with symbolic logic, then you will be familiar with how implication works. So false propositions, something like 2 plus 2 equals 5 implies that I don't know, the sun is the center of the solar system, something like that. This is a perfectly valid and true implication, but it sounds weird, right? From a psychological perspective, it sounds weird. And I think what he's getting at here is that these were the early days when this was kind of it's just like that kind of idea would be weird to somebody who comes across symbolic logic for the first time, but actually comes to accept that that's how implication works. At this time, everybody, I guess, was just being introduced to these kinds of ideas, and he's pointing out that the view of implication that we're accepting, it has these properties that seem a little bit strange. He goes on to say something in a couple of sentences that I'm going to comment on a bit more about. Where was I up to? So it would certainly not be commonly maintained that 2 plus 2 equals 4 can be deduced from Socrates as a man. So here we've got Socrates as a man, which is, okay, let's say it's a true proposition, implies 2 plus 2 equals 4. This seems weird to us, right? Because there seems to be something missing, which I'm going to talk about more in a second. But this is the view of implication that we take. That's a perfectly valid implication. Or that both are implied by Socrates as triangles. So as far as I know, Socrates is not a triangle, or never was a triangle. So therefore, Socrates is a triangle implies 2 plus 2 equals 4, and Socrates is a triangle implies that Socrates is a man. Again, it feels kind of weird because Socrates is a triangle. You wouldn't ever expect to utter a sentence like that. Socrates is a triangle. And you certainly wouldn't expect to deal with such a strange proposition. But again, the view of implication that we're taking allows us to form these implications, and they're true implications in our system. And then he goes on to say, but the reluctance to admit such implications is chiefly due, I think, to preoccupation with formal implication, which is a much more familiar notion and is really before the mind as a rule, even where material implication is what is explicitly mentioned. So formal implication is, we'll find, is the simultaneous assertion of a class of material implications. I don't really understand what he means when he says the reluctance to admit such implications is chiefly due, I think, to preoccupation with formal implication. I don't really know what he means by that. To me, the reluctance to admit such implications as Socrates is a triangle implies that 2 plus 2 equals 4. I think there's more of a psychological element to it. This is just me speculating, but I think there's kind of a psychological expectation that I think there's two psychological expectations. One is that in an implication, the hypothesis is likely to be true. It's either known to be true, or there's a reasonable expectation that it could be true. And also, I think that the two propositions that are related by this implication, we kind of expect there to be some connection. I'm going to use that in a very vague sense, but there's some psychological connection that we perceive between the two propositions. So Socrates as a triangle implies 2 plus 2 equals 4. There doesn't seem to be that clear connection there. Even if we've got true propositions like 2 plus 2 equals 4 implies that whales are mammals, or a whale is a mammal, whatever, right? We've got true propositions. You might argue that on some level that there is a chain of implications that we could choose that takes us from one to the other, but I think we do expect a certain proximity as well in the relation between the between the two propositions. These are purely psychological things, I know, and they've got no bearing really on the logical reality or what the logic dictates to us. But when he says that I think the preoccupation is with formal implication, I think the preoccupation is, in my opinion, more to do with these psychological aspects as opposed to this formal implication. But that's because I don't really understand what he's getting at with that. So in inferences from Socrates as a man, it is customary not to consider the philosopher who vexed the Athenians, but to regard Socrates merely as a symbol, capable of being replaced by any other man, and only a vulgar prejudice in favour of true propositions stands in the way of replacing Socrates by a number, a table, or a plum pudding. Again, so we kind of expect there to be some relevance, not just between the propositions, but actually within the proposition as well. So we tend not to say things like a plum pudding is a man, or a table is a man, or even to consider such propositions. Maybe we do consider such propositions on some level, but we don't really give them much heed. And yeah, I think we do have a preference for true propositions, and I think the hypothesis of a proposition, we in an implication we tend to try to start with a true hypothesis. What's the point in starting with something like 2 + 2 = 5 as a premise, as an initial premise? Now, it might be that in some cases the premise that we start with we don't know to be true. So let's say Riemann hypothesis. As of the time of making this video, as far as I know, the Riemann hypothesis hasn't been proved. It's still an open question. So what we might do is we might say, well, let's assume that the Riemann hypothesis is true, and see what happens. See what kinds of conclusions we can draw from that. But we accept that there is the possibility that it might actually be false. Okay, but importantly though, we are acknowledging that there is the possibility that it could be true. On the other hand, we wouldn't take something that we know to be false, such as 2 + 2 = 5, and start trying to deduce things from 2 + 2 = 5. So we do seem to have a preference for true propositions, certainly when these true propositions form the premise of an implication, I guess. Nevertheless, wherever, as in Euclid, one particular proposition is deduced from another, material implication is involved, though as a rule, the material implication may be regarded as a particular instance of some formal implication, obtained by giving some constant value to the variable or variables involved in the said formal implication. So more will be said about formal implication as we go in, but a formal implication is to be understood as the simultaneous assertion of a class of material implications. So our material implication is just one of that class of material implications that we're kind of picking on. And although while relations are still regarded with the awe caused by unfamiliarity, it is natural to doubt whether any such relation as implication is to be found. Yet in virtue of the general principles laid down in section C of the preceding chapter, there must be a relation holding between nothing except propositions, and holding between any two propositions of which either the first is false or the second is true. So this is harking back to section 30. So in section 30, if I can find it, I'm not going to bring it up on the screen, but I'll just read it out. So if U and V be any two classes, there is a relation R, the assertion of which between any two terms X and Y is equivalent to the assertion that X belongs to U and Y to V. So we can have, I think that's the bit that he's referring to there. So in Principia Mathematica, such a relation, so if we've got two classes, U and V, the relation that he's talking about here would be, he'd use that kind of notation. In Principia Mathematica, he'd probably use alpha and beta instead of U and V. I think it's in chapter 36, section D anyway, of part 1 of Principia Mathematica. That's the relation that he's kind of getting at, as far as I can see. And it's this that guarantees that we've got a relation that we're going to be able to call implication. Of the various equivalent relations, and I'll talk a bit more about that in a second, of the various equivalent relations satisfying these conditions, one is to be called implication. And if such a notion seems unfamiliar, that does not suffice to prove that it is illusory. Okay, so if you're unfamiliar with this, then okay, that's your problem, kind of thing. But what he's saying here, of the various equivalent relations satisfying these conditions. In other words, we've got implication, or let's say we've got this relation, implication, but there are also other relations which are equivalent to it. So when it comes to classes, Russell takes an extensional view of classes. The terms of a class, we cannot have, we don't have two classes with the same terms that are not identical. In chapter 6, he specifically forbids a class to be identified with its class concepts, because this would give rise to an intentional view of classes, in which we would have classes with the same terms but not identical. They'd be equivalent or equal even, but not identical. So he insists on an extensional view of classes, so that a class is determined by its terms. Okay, two classes which have the same terms are actually the same class. Okay, when it comes to relations, he takes an intentional view of relations. There's various reasons for this, but what that means is that we can have two relations that whenever x and y are related, so two relations R and R primed, such that x R y implies and is implied by x R primed y for all x and all y, for all terms x and y. Okay, so we've got this mutual implication. If this x R y holds if and only if x R primed y holds. So these relations will be, they're not identical, but they're equivalent. Okay, because we're taking an intentional view. So just like with class concepts, if we were to take an intentional view, we'd have the class of men and the class of featherless bipeds. But these classes would be different by virtue of the fact that man and featherless biped are different class concepts. Okay, so we take an intentional view of relations. So that means that if we that there's relations which are equivalent to implication of this class of equivalence. So let's go back to before we've chosen one to be the relation of implication. We've just got a class of equivalent relations, and we just pick one and we say that's the one that we're going to call implication. And then all of the others, they're equivalent to that relation, but they're not identical with it. So that's what he's getting at here. I think, if I remember rightly, it's a while since I've read it actually. In chapter 9 on relations, he does actually kind of identify or replace a given relation with the class of all relations equivalent to it, if I remember rightly. So that's in chapter 9, I think. I could be wrong on that one, though. Anyway, moving on. So, section 38. At this point, it is necessary to consider a very difficult logical problem, namely the distinction between a proposition actually asserted and a proposition considered merely as a complex concept. So he spends some time on this. And so there's a lot of talk about this in chapter 4. And a proposition actually asserted has something to do... So it's something to do with the verb. So a verb is an essential part of a proposition. It plays an essential role in a proposition, according to Russell. And a verb can have different grammatical forms, and it plays different roles, therefore, in a proposition. So a verb can play the role of an actual verb. So the example that he uses in one of the chapters is Caesar died. I think it's in chapter 4. Caesar died. So died is a verb in its role as a verb. Okay? And Caesar died is a proposition, and it can be asserted. On the other hand, we've got the death of Caesar, where the verb has a different grammatical form there. It's in the form of a verbal noun, the death of Caesar. Okay? And this is... The difference is, according to Russell, and don't ask me how this works, we've got to take his word for it. In the version where we've got the verb in its role as a genuine verb, the proposition is either contains its truth or its falsehood as an element of itself. And it's the verb, according to Russell, that seems to provide that. Whereas when we switch to the other form, the death of Caesar, he says that it's still this that's true or false, but this doesn't contain its truth or falsehood in itself as an element. I don't claim to fully understand this argument, but this is what he says. And it seems to be this that's kind of the difference between an asserted proposition and an unasserted proposition. A proposition that's merely considered as he puts it here, a complex concept. So in the latter case, the death of Caesar can be used as the subject in another proposition. So it's unasserted, and it can be used as a subject. But also Caesar died. We don't have to assert this, and we can use Caesar died as the subject in another proposition. So he does admit in chapter 4 that there are certain difficulties with this view that he hasn't resolved. And I've certainly not come to any resolution to these difficulties. But again, what I've said in previous videos is that these videos are really designed just to really intended just to present Russell's arguments and Russell's views, however strange they might seem from time to time. I'm not trying to necessarily apply any substantial critical analysis, although that doesn't prevent me from commenting from time to time on what he says and adding my own thoughts to things, so I'm not it's just that's not the aim of these videos, to tear Russell apart. There's plenty of opportunity for that if you want to do that, but that's not the aim of these videos. So okay, one of our indemonstrable principles was, it will be remembered, that if the hypothesis in an implication is true, it may be dropped and the consequence asserted. So he's kind of referring back to a previous chapter here. This principle, it was observed, eludes formal statement and points to a certain failure of formalism in general. The principle is employed whenever a proposition is said to be proved, for what happens is, in all such cases, that the proposition is shown to be implied by some true proposition. So, in other words, maybe get rid of some of this. So what he's saying here is that we've got an implication. So P implies Q. And P is a true proposition. Then we can assert Q. Okay, so this is very familiar to people. If you're familiar with symbolic logic and things like that, you'll be very familiar with this kind of argument. Modus ponens or detachments. It's got all sorts of different names. What he's saying here is that this principle, it eludes formal statements. Okay, and he's going to show that there is something, as we go on, there is something that seems to resemble this, that would seem to be this, a formal statement of this idea, but it doesn't work. Okay, so there's some principle that's at work here that eludes formal statements, that allows us to go from these two to this. And what he's saying is that's what happens when we prove something, right? It's not the implication. I need to rotate my pad. This P implies Q. This will hold even when P is false, right? So again, this is one of the quirks of the view of implication that we take. We don't require P to be a true statement, a true proposition. P could be false, in which case we can't go to Q and we don't have a proof, right? So we can have this chain of implications from some weird false proposition. We can have a chain of implications, but we can't prove anything. To prove things, we need true propositions to form the premise of each implication that's involved. Okay, and then we need a way of kind of eliminating those true propositions, getting them out of the way, so that we can eventually get to the thing that we want to prove. But there's some principle at work there. This will be very again, if you're familiar with symbolic logic, there won't seem to be anything strange here. But this was, again, going back to the early days of symbolic logic, where these kinds of ideas were they were known quite well, I would imagine, to some people, to some individuals, but they weren't necessarily as widespread as they are now. Okay, so where was I up to? Another form in which the principle is constantly employed is the substitution of a constant satisfying the hypothesis in the consequence of a formal implication. If phi x implies psi x for all values of x, and that is a formal implication, the if phi x implies psi x for all values of x, and if a is a constant satisfying phi x, we can assert psi a, dropping the true hypothesis phi a. This occurs, for example, whenever any of those rules of inference which employ the hypothesis that the variables involved are propositions are applied to particular propositions. The principle in question is therefore quite vital to any kind of demonstration. The independence of this principle is brought out by a consideration of Lewis Carroll's puzzle, What the Tortoise Said to Achilles. So I read this a number of years ago. I've not read it recently. Maybe I should have done. So I can't remember exactly what it says. So I'm going to go through this. I might not be able to say too much about this part. Although there are still some comments that I can make. The principles of inference which we accepted leads to the proposition that if P and Q be propositions, then P together with P implies Q implies Q. Okay, so we've got P and Q propositions. And if P together with, all right, so P and P implies Q implies Q. Right. So if it happens that P and P implies Q are both true, then we might be tempted to jump to Q. But unfortunately, this symbolic formula, this formal statement, whatever you want to call it here, it doesn't say that we can do that, right? It doesn't say that we can just drop the P and the P implies Q and just assert Q. So there has to be something else, some other principle that tells us that in this case we can do such and such. Okay, when we've got P true and P implies Q true, then we can assert Q. So there is scope for confusion here, that this does seem to resemble what I was just talking about. So this kind of idea here, P implies Q, P true, then Q, but there isn't anything there. There isn't some principle there that tells us that we can just assert Q. But this principle that's being used, it can't be formalized. Okay, that's part of the difficulty. So at first sight, it might be thought that this would enable us to assert Q, provided P is true and implies Q. But the puzzling question shows that this is not the case, and that until we have some new principle, we shall only be led into an endless regress of more and more complicated implications, without ever arriving at the assertion of Q. We need, in fact, the notion of therefore, which is quite different from the notion of implies, and holds between different entities. In grammar, the distinction is that between a verb and a verbal noun, between, say, A is greater than B, and A's being greater than B. In the first of these, a proposition is actually asserted, whereas in the second, it is merely considered. So in the first case, we've got a noun is in its role as an actual noun. So in that proposition is asserted, and we view the noun, did I say noun or verb? It's a verb. The verb is in its role as an actual verb. Sorry for any confusion. I can't remember if I said noun or verb. So in that proposition, A is greater than B, if that's asserted, then we're also viewing the verb there as a relation which is actually relating A and B. So when we use a verb in its role as an actual verb, then it's representing a relation which is actually relating A and B in this case. On the other hand, A is being greater than B. Being is a verbal noun here, right? So in this case, this is effectively an unasserted proposition. We're just considering the proposition as a complex concept. And the verb now, in its form of a verbal noun, it still represents a relation, but we don't consider it as a relation actually relating anymore. It's just a relation in its kind of in isolation, so to speak. This is the view that Russell takes. I'm not necessarily agreeing with it, and I'm not claiming to fully understand it, but this is the view that he seems to take. But these are psychological terms, whereas the difference which I desire to express is genuinely logical. It is plain that, if I may be allowed to use the word assertion in a non-psychological sense, the proposition P implies Q asserts an implication, though it does not assert P or Q. So he's going to talk about this at length here. The P and the Q which enter into this proposition are not strictly the same as the P or the Q, which are separate propositions. at least if they are true. So what he's going to get into in a minute is, does assertion, if we've got a true proposition, so a proposition that can be true, is it the same proposition when it's asserted as when it's unasserted? Because there does seem to be a difference between the two. There seems to be something, assertion, that is different between the two propositions. At least between the proposition when it's asserted and when it's not asserted. There seems to be something that's some difference there. But what is the nature of that difference? It's difficult to determine. And if there is a difference, then arguably the P that is asserted and the P that occurs in P implies Q, which is unasserted, the P that occurs here is unasserted, then if there is a difference between an asserted proposition and an unasserted proposition, then this P is not the same as this P. They're two different propositions, effectively. Now, you could argue that Russell's reading far too much into this and making a mountain out of a molehill. And there might be something in that, in saying that. But this is the view that he's taking. You know, what is this assertion? What is the nature of this assertion? Does it add anything to a proposition? If a proposition is true, does it automatically follow that it's asserted? Can a true proposition be unasserted? Can a false proposition be asserted? And so on and so forth. So he doesn't have a definitive answer to this. But let's read on. The question is, how does a proposition differ by being actually true from what it would be as an entity if it were not true? It's plain that true and false propositions alike are entities of a kind, but that true propositions have a quality not belonging to false ones, a quality which in a non-psychological sense may be called being asserted. So it seems that true propositions have this property of being asserted, or the capability, the possibility of being asserted. But notice that he says that true and false propositions alike are entities of a kind. So I've said in a previous video that at some point in Russell's career, possibly around the time of Principles of Mathematics, his view evidently was that there are facts, objective facts, I guess. Don't quote me on this, but there are kind of objective facts, and to each fact there corresponds two propositions, a true proposition and a false proposition. So that presumably these propositions are, as he says here, entities of a kind. They're the same kind, same category of object. It's just that one has a certain relation to the fact, which makes it true, and the other has another relation to the fact, which makes it false. And that was another thing. He didn't actually consider both of these propositions having certain relations to the fact. It has been suggested in another book that I read on Russell's view in this respect that Russell didn't seem to consider the possibility that a false proposition might just not have any relation to the fact. I mean, that might be a valid view, but actually I would tend to agree that if there are true and false propositions corresponding to a fact, that they've both got some relation to it, and not that one has no relation to it. The false proposition has no relation to the fact. Because then how does it correspond to the fact? I don't know. I don't know enough about this stuff. There'll be lots of people that are much more philosophically minded who know way more about this stuff than I do. Okay, yet there are grave difficulties in forming a consistent theory on this point. For if assertion in any way changed a proposition, no proposition which can possibly in any context be unasserted could be true, since when asserted it will become a different proposition. So that's the situation that we're in here, right? So if assertion in any way changed a proposition, no proposition which can possibly in any context be asserted could be true. there's some difference in the proposition potentially. But this is plainly false, for in P implies Q, P and Q are not asserted, and yet they may be true. Leaving this puzzle to logic, however, we must insist that there is a difference of some kind between an asserted and an unasserted proposition. When we say therefore, we state a relation which can only hold between asserted propositions and which thus differs from implication. Wherever therefore occurs, the hypothesis may be dropped and the conclusion asserted by itself, and this seems to be the first step in answering Lewis Carroll's puzzle. So this is the extra principle that he's talking about, that therefore is different from implication, and therefore it's different from this thing here. And this extra principle, when we've got this relation of therefore between certain propositions, it's this principle that allows us to drop the hypothesis and assert the conclusion by itself. So, section 39, it's commonly said that an inference must have premises and a conclusion, and it is held apparently that two or more premises are necessary, if not to all inferences, yet to most. This view is borne out at first sight by obvious facts. Every syllogism, for example, is held to have two premises. Now, such a theory greatly complicates the relation of implication, since it renders it a relation which may have any number of terms and is symmetrical with respect to all but one of them, but not symmetrical with respect to that one, the conclusion. This complication is, however, unnecessary. First, because every simultaneous assertion of a number of propositions is itself a single proposition. And secondly, because by the rule which we called exportation, it is always possible to exhibit an implication explicitly as holding between single propositions. Okay, so Russell's arguing for the view that implication holds only between single propositions. So P implies Q. Now, what he's saying then is that if we've got a class of propositions, K, which may be finite or infinite, there is a proposition which simultaneously asserts all of the propositions in that class. So it's not necessarily an infinite logical product, let's say. It's just a single proposition which asserts all of the propositions of that class, and it says it's for all values of x, if x implies x. Oh, okay, so I'll read on just for a second then. So to take the first point first, if K be a class of propositions, all the propositions of the class K are asserted by the single proposition for all values of x. If x implies x, then x is a K implies x. So that's a single proposition implying another proposition. Or in more ordinary language, every K is true. And as regards the second point, which assumes that the number of premises is finite, so we're taking here our class K to be finite. In this case, we've got PQ implies R. So this is, I'll go back to this in a second in the book. PQ implies R is equivalent to, if Q be a proposition, so Q is a proposition, then, where is it? I lost it. Q be a proposition to, then P implies that Q implies R. Okay, so I'll just put a little bracket around this. Russell doesn't use the brackets, but just to make it clear what's implying what. So P implies that, Q implies R. So these are equivalent, and this is called exportation. And this is from chapter 2. So it's if you turn to section 18, it's statement number 8 that he's referencing there. So what he's saying here is that if we've got a finite number of premises, then we can, if we want to, form a single proposition by forming the logical product of all of these premises. But also what we can do is, but then we've got multiple premises. What we can do is, using this exportation, we can kind of split that logical product up into a series of implications. So here we've got PQ implies R, the logical product of P and Q implies R. We can split that into P implies Q implies R. So if we've got P, Q, and S implies R, then we could have P implies Q implies S implies R. So each of the implications then is strictly relating to propositions. Okay, so the implication is a relation between two propositions, between single propositions, in other words. That's what he's arguing for here. Now you will see this cropping up quite a lot. So if we go back to that, where was it, section 18? In statement 8, it says if P, it starts out in a strange way. So this is from section 18. If P implies P and Q implies Q, then if PQ implies R, then P implies that Q implies R. So it starts out with P implies P and Q implies Q. That seems like a really strange thing to say, but there is a good reason why he inserts these little implications in from time to time. And he could have done the same thing here, where he says if Q is a proposition, he could have actually said if Q implies Q here. Okay, so this goes back to something that he says in, I'm going to have to find it now, I think it's right at the end of chapter 1, I think. No, it's not. Where is it? Ah, here we go. So chapter 2, section 16. What he says is that, so I'll just read it out. So it may be observed that although implication is indefinable, proposition can be defined. Every proposition implies itself, and whatever is not a proposition implies nothing. Hence, to say P is a proposition is equivalent to saying P implies P, and this equivalence may be used to define propositions. So this is going to be really important when he comes on to formal implications. This is this strange little implication which creeps in. In fact, we've already seen it actually in this. I'll repeat it in a second. It can be used to take something that is not quite a formal implication, and so if there's a variable in something that we want to be a formal implication has to hold, in Russell's view, for literally all terms. So if there's a variable in the formal implication, that variable has to have strictly unrestricted range. Okay, it cannot have a restricted range for it to be a formal implication. But this causes all sorts of problems, because there are certain formal implications where the formal implication only works when we restrict to certain categories of objects, in particular propositions. Okay, so the two possibilities that we've got open to us is we can either decide we allow formal implications for restricted variables, which Russell doesn't go for, or we can find a way to kind of effectively remove a restriction from a variable. So if a formal implication only holds, let's say, for propositions, but we need the variable to range over all terms where the propositions are not. What we can do is we can slip in this little implication, such as Q implies Q. And this will, in a lot of cases, effectively remove the restriction on that formal implication. It does produce a slightly different formal implication, or a slightly different proposition, let's say, but it's effectively it's like what we originally had, but with just a much greater range for the variable. So more will be said about this in the next section, but we've already seen this. So a couple of lines ago, here in section 39, when he says, to take the first point first, if K be a class of propositions, all the propositions of the class K are asserted by the single proposition for all values of X. If X implies X, then X is a K implies X. We're going to see in section 41 what the significance of that X implies X has, because he's going to consider this proposition effectively without that in. We're going to have this situation where we don't quite have a formal implication unless we kind of restrict the range of the variable, but slipping that in relieves that. It removes that restriction. Okay, so coming back to what we said here, PQ implies R is equivalent if Q be a proposition to P implies that Q implies R, in which latter form the implications hold explicitly between single propositions. Hence we may safely hold implication to be a relation between two propositions, not a relation of an arbitrary number of premises to a single conclusion. Section 40. Okay, so I'm probably just going to read through this and make a couple of brief comments on it. So I come now to formal implication, which is a far more difficult notion than material implication. In order to avoid the general notion of propositional function, let us begin by the discussion of a particular instance. Say, X is a man implies X is a mortal for all values of X. The proposition is equivalent to all men are mortal, every man is mortal, and any man is mortal, but it seems highly doubtful whether it is the same proposition. It is also connected with a purely intentional proposition in which man is asserted to be a complex notion of which mortal is a constituent. But this proposition is quite distinct from the one we're discussing. Indeed, such intentional propositions are not always present where one class is included in another. In general, either class may be defined by various different predicates, and so it is by no means necessary that every predicate of the smaller class should contain every predicate of the larger class as a factor. So, just because one class is contained in another class, whatever the predicate is, let's assume that we've got predicates that determine each of the classes. So there's a predicate that corresponds to the smaller class. There's a predicate that corresponds to the larger class. And the smaller class is, let's say the smaller class is entirely contained within the larger class. So every term of the smaller class is a term in the larger class. This doesn't mean that the predicate of the larger class is necessarily a component in the predicates of the smaller class. Okay. As he points out, indeed, it may very well happen that both predicates are philosophically simple. Thus, colour and existence appear to be both simple. I'll have to take his word for that. Yet the class of colours is part of the class of existence. So, when it comes to, so the class of colours is part of the class of existence, but the predicate existence is not a component part of the predicate colour. So therefore, he says the intentional view, which this is, the intentional view derived from predicates is in the main irrelevant to symbolic logic and to mathematics, and I shall not consider it further at present. So we don't consider the intentional view of formal implication, we consider only the extensional view of formal implication. So section 41, how we're doing. So maybe I'll actually leave it there. I didn't get anywhere near as much as I expected to with this. It's a relatively short chapter, but there's just so much going on in this chapter. I think I'm going to leave it there, otherwise the video is going to end up going on forever. Section 41's a long section and there is a lot to say about it, so I'll leave that for the next video. So any questions, feel free to ask. Hopefully I will be able to get to the end of chapter 3 in the next video, but I'm not too sure, to be honest with you. Let's keep our fingers crossed. Yeah. Okay, so thank you for watching. Again, I'd be really grateful if you would subscribe to the channel and hit the like button, and I will look forward to seeing you in the next video.